Kia ora. Today we're going to talk about how we recognise what's going on with the dipoles. So you always have these two answers that you write where the bonding regions are unevenly distributed, therefore the dipoles don't cancel out and the molecule is polar, or they are evenly distributed, they do cancel out and the molecule is non-polar. Before you can choose which of these two answers to write, you first of all have to work out what's going on with the dipoles. So let's have a look at a couple of examples. Here I've got methane. It's made of one carbon atom in the middle and 4 hydrogen atoms around the outside. These are all hydrogens here. And the carbon is in the middle. Now if we look at the periodic table, hydrogen sits over here on the top left and carbon sits at around about there on the periodic table, much further right. And as we go in this direction, atoms become more electronegative. That means their ability to draw electrons to them increases. All of these bonds here are covalent bonds. That means they're all sharing the electrons, but because hydrogen is less electronegative than carbon, they're not being shared equally, and most of the time the electrons spend their time around the carbon atom and less time around the hydrogen atom. So we say that there is a dipole in this direction. Okay, so all these dipoles are pointing in the same direction with equal amount of effort. Okay, because this is a three-dimensional object, you can see that I very deliberately chose this molecule structure to bring in the three-dimensional thinking to you. You must think about molecules in three-dimensional space being able to have parts of their molecules behind and in front of the central atom, and just like this one does. And so the angle between this bond and this bond is 109.5 degrees, and each dipole is equal in size and in direction because all of the bonds are carbon to hydrogen bonds. So therefore there is symmetry. So they are symmetrical in the way that they pull. That means they do cancel out. And so this molecule of methane is non-polar. Okay, let's look at a very similar example, but with one very significant difference, and have a look to see what happens when the opposite is going on. This molecule is chloromethane. We've got a chlorine atom there. We've still got the carbon atoms and the hydrogen atoms that we had in the other molecule. It's tetrahedral in shape, just like the methane is tetrahedral, but you can see that the chlorine is quite different. The carbon to hydrogen bonds are still dipoles. They're still going in the same direction. They still spend more time. Those electrons spend more time around the carbon than they do around the hydrogen. And so all of those bonds are pulling slightly in towards that direction, into the center of the carbon. However, the chlorine to carbon bond is different. So if I draw my periodic table again, I've got hydrogen, carbon, and chlorine is almost fully on the right hand side. That means that, remember, this is more electronegative in this right hand direction. And so chlorine is more electronegative than carbon. So that means that this bond pulls in the opposite direction. It doesn't actually matter whether it pulls in the opposite direction or moves in the same direction. All that matters for symmetry is that this molecule or this atom that's attached here is different to the others. It could be that you've got 2 chlorines. They'd still be different than 2 hydrogens. And so because they are different and the electronegativity is different for each of them, they are not symmetrical. Okay? And so if they're not symmetrical, that is another word for that we commonly find in textbooks and in videos is asymmetrical. Oops. It would help if I could spell. I'm still not sure I've spelled that right. Not symmetrical is the same as asymmetrical. This means that the dipoles don't cancel out because they're different. They can't cancel. And if they don't cancel out, then we have a molecule that is polar. Okay, so it's really important that we look at the different kinds of bonds that are around the central atom, and if they have different electronegativity between them, then it will not be symmetrical and it will not cancel out. Okay, ka kite anō.